All right, so in this last video, what we're going to talk about is standing waves. And what a standing wave is when you have a wave that's moving in one direction that's interfering with another wave of the same amplitude and frequency, or the same frequency in another direction. The waves seem to have a repeating pattern, and they look like they're standing still, and that's where the name standing waves comes from. So two waves need to be passing each other by. They need to be lined up in a way that their amplitudes based on the frequency are compiling, and we end up with what is referred to as a standing wave. And I'll show you what this means. There's a video next that shows a good example of this. Again, when the wave is not moving and it seems to have the same pattern, that is why they call it a standing wave. I want to talk about, and you can see a picture of a standing wave lower on your notes. I want to talk about different points in a standing wave, because when a wave is standing, there seems to be spots where the medium is moving and spots where the medium is not moving. The places where it doesn't seem to be moving is called a node. The reason why the medium doesn't appear to be moving in this spot is because there's a maximum destructive interference happening at this point, meaning the waves that are interfering with each other are always acting opposed to each other at this location in the medium. Because they have maximum destructive interference at that point, we say that it's a node that has zero amplitude always. The antinode, which you can again see on the diagram down below, also identifies where there's a maximum constructive interference. That means that the amplitudes are adding together at this point, and this is a point that seems to be moving. So the points that are at equilibrium are the nodes. The points between the equilibrium, and if you're looking at the diagram on your page, these are the ones that, like the bulbous areas, those are the areas where you have constructive interference. So standing wave is really when you have alternating constructive and destructive interference due to the interference of two waves interfering, moving in different directions. One last note that you have to understand about standing waves is that the distance between any two nodes is 1/2 of the wavelength. So if you ever have a diagram of standing waves, you can always identify what the wavelength is by just doubling the distance between any two nodes. This diagram you can see on your page, and this is just a summation. I'm going to define node and antinode here. The nodes are the spots where it's at equilibrium, kind of the midpoint. That's zero displacement, maximum destructive interference. The antinodes are the bulbous parts between the nodes here and here. Those are points where you had the largest displacement and the most maximum constructive interference. In the video that you're about to watch, they show a demonstration of standing wave using a slinky. I think this will help. You'll also see one when you get back to class. But watch that video, try a couple of example problems, and then try the CAS Learning. That'll show you all the different things about wave interference, and we will talk about this more when we come back next week.